Greetings and welcome to Mz.Rootz online education sessions. Learning objectives. This session, you will be making progress through Module 2, which is for you to be able to use geological references to study Africa. This module is broken up into 2 parts. This session will focus on the first part, 2.1, and by the end of the session you should be able to identify how Africa has changed geologically from prehistoric times. By the end of this session, it is with my intention that you will be able to describe geology in relation to Africa and also to compare and contrast Earth's history with African history. For this session, you may need your book, journal or folder with your pens to make notes, your course content checklist to keep track of your progress. If you haven't already, this is downloadable within the formal session 1. Your African history timeline. Again, if you haven't already, you can download this within the formal session 1, and an electronic folder on your system where you should be keeping all of your documents centralized and organized. For this session, you are going to need to download the Geological worksheet. Check the description box within this session. The link is there. Press the link and that worksheet is yours. The continental drift theory. How many of you have heard of this theory? What is this theory all about? This is Earth, our globe, spinning, and I wonder how many of you are able to outline what each part of the globe consists of. Are you able to label the continents, countries, cities, the oceans? Well, if the answer is no, then by the end of module 2, if you complete all the activities and pay close attention to the discussion and the content, then you will be able to have quite an in-depth knowledge of the globe, both in its present form, in its prehistoric form, and also be able to discuss how it may look in the future. But before we get into the main body of this session, it's imperative that you know a couple of keywords. The first word being geology. What is geology? Geology is the study of the Earth, its processes, its materials, its history, and its effect on humans and life in general. From that definition, I hope you're starting to make connections with why this is linked with African studies and African history. I quite often advocate the notion of linking subjects and having a holistic perspective on human history, which of course is Earth's history. The second keyword that Mz.Rootz feels you should be fully aware of is the term prehistoric. How many of you can correctly define this term? Pre, well, we know is something that happened before, and historic, wow, this is where it gets a bit complicated. Let's take a look. Prehistoric refers to anything which preceded written accounts. So that's anything before the invention of writing, around 5,000 years ago, is considered prehistoric. Before recorded history, such as dinosaurs, fossils, the formation of the continents, are all prehistoric. This would be a good time to refer to our African history timeline and consult the time period in which we are talking about. I'm going to take my arrow and I'm going to point to around here, which is 6,000 years before Common Era. So this point in time here would be considered prehistoric, before we were writing things down. We have evidence of existence via fossils, rocks, and today's focus is geology. I'm going to point to the time period in which the continental drift theory is referring to. You see this plus sign here that I'm circling? This is the time period that is not documented on our African history timeline, but I do have a resource that will detail what happened before we start talking about human evolution on the continent of Africa. Let's take a look at Earth's geological history and its relation to the continent of Africa. Earth is 4.6 billion years old, give or take a few 100 million years. The age of Earth is so long compared to all periods of time that we humans are familiar with. It has been given a special name, geologic time, to help show the span of time since the formation of Earth. The stairway of time has been created. The bottom of the stairway represents the formation of Earth 4.6 billion years ago. The top represents the present, or today. The different steps represent different segments of time in Earth's history. Something different was happening during each segment. The odd names of the different time periods on the staircase of time were made up by geologists who were the first people really interested in finding out the actual age of the Earth. Most of the names have to do with places where certain types of fossils were found. The word fossil means things dug up, but now we usually use it to refer to any evidence of past life buried in the ground. It is by studying fossils that we first began to discover how much really happened on Earth. We, as modern humans, divide up the year into months, weeks and days. Geologists divide the history of Earth into several different time periods. The longest time period geologists use is called an eon. Eons are divided into shorter time periods called eras, and eras are divided into even shorter times called periods. On the staircase of time, the different coloured sections of the staircase show the different eras. For instance, the steps within the Precambrian eon represents different eras, while the remaining steps represent different periods. The Precambrian eon, 4,600 million years before Common Era to 2,500 million years before Common Era. The name means before the Cambrian period. This term was originally used to refer to the whole period of Earth's history before the formation of the oldish rocks with recognizable fossils in them. In the last few decades, geologists have found that there are some hard to discern fossils in some Precambrian rocks. So this period also is known as the Cryptozoic or obscure life eon, from the words crypt, which means hidden, and zoon, which means life. This eon covers almost 90% of the entire history of Earth. It has been divided into 3 eras: the Hadean, the Archaean, and the Proterozoic. Each era is very different. Hadean, Hades-like era, 4,600 million years before Common Era, lasting until 3,800 million years before Common Era. This era begins about 4.6 billion years ago with the formation of Earth from dust and gas orbiting the Sun. During this era, the surface of Earth is like popular visions of Hades, oceans of liquid rock, boiling sulfur, and impact craters everywhere. Volcanoes blast off all over the place, and the rain of rocks and asteroids from space never ends. It is hard to take a step without falling into a pool of lava or getting hit by a meteor. The air is hot, thick and steamy, full of dust and crude. It was made of nothing but carbon dioxide and water vapor, with traces of nitrogen and sulfur compounds. Any rocks that do form from cooling lava are quickly buried under new lava flows or blasted to bits by yet another impact. Some people think that an asteroid as large as the planet Mars hit Earth near the beginning of the Hadean Era, completely smashing and melting Earth and forming the Moon as part of the splash. No rocks have ever been found on Earth from this era, only meteorites from space, and moon rocks are this old. If any life formed on Earth during this era, it was probably destroyed. The Archaean, meaning ancient or primitive era, existed between 3,800 million years before Common Era until 2,500 million years before Common Era. This era begins about 1 billion years after the formation of Earth, and things have changed a lot. Mostly everything has cooled down. Most water vapour in the air has cooled and condensed to form a global ocean. Even most of the carbon dioxide is gone, having been chemically changed into limestone and deposited at the bottom of the ocean. The air is now mostly nitrogen, and the sky is filled with normal clouds and rain. The lava also is mostly cooled to form the ocean floor. The interior of Earth is still quite hot and active, shown by the many erupting volcanoes. The volcanoes form lots of small islands in long chains. The islands are the only land surface. The continents have not formed yet. The islands are carried over the surface of the Earth by the movement of rock deep in Earth's interior. This movement results from the loss of heat from the deep interior and is called plate tectonics. Occasionally, the small islands collide with each other to form larger islands. Eventually, these larger islands will collide to form the core of the continents we know today. There is evidence stating life on Earth then was a single-celled bacterium. Blue-green algae, actually simple bacteria floating in the ocean. There is no life on Earth. Life began in the ocean near the beginning of this era. The oldest known fossil remains of different types of bacteria are found in Archaean rocks about 3.5 billion years old. The surface of the Earth is still very active, but a few of the rocks that are forming now will actually survive to the present in spite of wind, rain and remelting. Geologists define the beginning of the Archaean Era as the age of the oldest rocks on Earth we can still find today. Proterozoic, meaning early life era, occurred 2,500 million years before Common Era and lasted until 570 million years before Common Era. In this time, there is a lot more land to be seen. In fact, there are 2 supercontinents, one visible across the equator on this side of the Earth and the other on the other side. These huge land masses were formed by collisions of many islands made by volcanoes during the Archean and most of the Proterozoic eras. Earth's interior has cooled down some more, and there are fewer volcanoes than in the Archean. The movements of Earth's surface we call plate tectonics are still very fast, and continental collisions are frequent. The centre or the cores of the continents are now quite large and stable. Life has not changed much during the last 2 billion years, but The few changes are significant. Life is still found only in the ocean, but sometime around 1.7 billion years ago, single-celled creatures appeared that had a real nucleus. Another important change is about to happen. Multi-celled life is about to appear. These multi-celled creatures will have no hard parts like shells or teeth in their bodies, so their fossils will be hard to find. The atmosphere is about the same, mostly nitrogen with a little water vapor and carbon dioxide. But oxygen is released by the algae floating in the oceans, and it's beginning to collect the air. These single-celled plants have been producing oxygen for about 2 billion years, but up until now, the oxygen has been combined in chemically with iron and other elements to form great mineral deposits around the world. Paradoxically, the oxygen which we must have to live is poisonous to most of the life forms living on the Earth during this era. Earth at this time is very cold, with huge bluish glacier ice sheets visible across the supercontinent, even in the normally warm equatorial regions. Phanerozoic, meaning evident life. This occurred between 570 million years before Common Era to the present day. This is the first of 3 geological eras squeezed into the last 10% of Earth's whole geological history. This last 10% of Earth's history is called the Phanerozoic Eon, or Eon of Evident Life. The rocks found from this era contain lots of fossils. The Paleozoic Era, meaning ancient life, occurred 570 million years before Common Era and ended 245 million years before Common Era. The Paleozoic Era lasted about 325 million years. So much happened during this era that it is divided into 7 geologic time periods shown on the red steps in the staircase of time. Many different things happened during this period. Earth's interior has cooled down to something like modern levels. Volcanic activity has reduced to a few minor eruptions like Mount Helen each year, and major ones like Krakatoa every century or so. However, gigantic hotspot type eruptions still occur every 100 million years or so. Plate tectonics continue to push land masses across Earth's surface. At this particular time, in the middle of this period, most of the land is still locked in 2 supercontinents. Huge glaciers cover the interior of one of the continents, called Gondwanaland, and Earth is experiencing one of its ice ages. On the other side of the globe is the other continent called Laurasia. Over the next 100 million years, these continents move over the equator and begin to break up, and the climate warms up substantially. The composition of the atmosphere has continued to slowly change, mostly due to the increase of oxygen produced by photosynthesis, algae floating on the ocean. By the Paleozoic, the composition of the air has reached something like what we breathe now, about 4/5 nitrogen and 1/5 oxygen, and small amounts of carbon dioxide, water vapor, and other gases. The air is capable of supporting large animals, and almost in response, life explodes into the Paleozoic. At the beginning of the Paleozoic, life existed only in or near the ocean. Shellfish, corals and sponges appear, followed by the first fish. Land plants appear near the end of the Ordovician, and for the first time we see the green of the land plants in our global view. Huge forests and swamplands form during the warm climates of the Mississippian and the Pennsylvanian periods that later fossilized into the giant coal beds of the eastern United States. Animal life also moved onto the land. First, the arthropods, which are spiders and insects, then the amphibians, and later the reptiles. The most abundant animals on land and sea during the Paleozoic were those like shellfish and insects that lacked backbones. So, the Paleozoic is also called the age of the invertebrates. The Paleozoic was also marked by several mass extinctions, geologically short periods of time during which large numbers of life forms died out. Mass extinctions occurred at the end of the Paleozoic was also marked by several mass extinctions, geologically short periods of time during which large numbers of large forms died out. Mass extinctions occurred at the end of the Ordovician and the Devonian, and the worst one of all at the end of the Permian, which was about 95% of all life on Earth which died. These mass die-ins were probably caused by climate changes and periods of giant volcanic eruptions. We can follow the development of life in detail during the Paleozoic because at the beginning of that era, life forms developed hard parts like shells, teeth, bones, and woody parts that were easily preserved as fossils. Mesozoic Era, also known as Middle Life, occurred between 245 million years before Common Era to 65 million years. This is the second of the three geologic eras squeezed into the Pharozoic evident life eon that covers the last 10% of Earth's whole geological history. This is the era when we think the ancient Earth was rampaged by dinosaurs. The Mesozoic era lasted about 180 million years, from about 245 million years ago to about 65 million years ago. The Mesozoic is divided into just 3 time periods: the Triassic, the Jurassic, and the Cretaceous. The supercontinents Gondwanaland and Laurasia collided some time back to form a single supercontinent called Pangaea, meaning all Earth. But the plate tectonics continues its irresistible motions, and even as we look, Pangaea is beginning to break up into the continents we know today. At upper left, North America is just breaking away from the northwest coast of Africa, and the Atlantic Ocean and Gulf of Mexico are all beginning to form. The mountains of the eastern United States are high and rugged. Ranges like Rocky Mountains are today. Over the next 50 million years or so, South America, India, and the Antarctica will all break away from Africa and move towards their present positions. Life is diversifying rapidly and beginning to look familiar. The dominant animals on both land and sea are reptiles, the most famous of which are the dinosaurs. Dinosaurs began in the Triassic, spread during the Jurassic, and dominated the Earth during the Cretaceous period. They are so predominant that the Mesozoic is also called the Age of Reptiles. Dinosaurs were not the only life form around. Birds and mammals also appear during this era, as well as trees and flowering plants. The climate during this era is warm, so warm that there are no ice caps at all, even at the poles. Plants grew like crazy in the warmth and moisture, so there is food everywhere. A mass extinction, like those in the Paleozoic, ended this era. More than half of all existing life forms disappeared, including virtually all of the dinosaurs. There are many hypotheses as to why this happened, including disease, volcanic eruptions, and giant impacts. That brings us to our last period, Cenozoic, meaning recent life. This occurred between 65 million years before Common Era to present day. This is the last of the 3 geologic eras squeezed into the Phanerozoic Eon, meaning evident life, that covers the last 10% of Earth's whole geologic history. This is the age of mammals, in which whales took over the oceans, saber-toothed cats shared the land with elephants, and humans finally appeared. This period began, as I say, about 65 million years ago with the extinction of dinosaurs, and continues right through to present day. And it's divided into just 2 time periods, the Tertiary and the Quaternary. The view of Earth is that of today. During the last 60 million years, Pangaea has broken up into the continents, and they have moved into the position which we see them now. The Atlantic Ocean has opened from a narrow valley to a vast ocean. India has moved across the Indian Ocean and collided with Asia to make the Himalayan mountains. North and South America have moved westward over part of the Pacific Ocean. The pressure has crumpled the western coasts of both continents to form the Rocky Mountains. Part of the Pacific sea floor has been forced into the warm interior under the American continent, causing melting and the formation of the Cascade and the Andes volcanoes on the surface. The global climate has turned somewhat colder, and the last few million years have seen the return of giant glaciers and ice caps to the North America, Eurasia and the Antarctica. After the disappearance of the dinosaurs, there were suddenly many empty places on Earth where animals could live. Mammals, which were small, mouse-like animals at the beginning of the Cenozoic, quickly spread out, diversified in kind, and grew in size. Soon the plains and the forests of the earth were occupied by giant rhinos, elephants, lions, saber-toothed cats, horses, deer. The sky filled with bats and birds, and the sea filled with whales and tortoise and all sorts of octopi and fish. Humanity appeared during the last approximately 5 million years. In the last 10,000 years, a blink of an eye in geologic time, humanity has spread across the lands and sea of Earth, altering the face of Earth with cities and farms, destroying some plants and animals and domesticating others. Humans have become the dominant terrestrial life form, more numerous than any other large animal and more fearsome than the most terrible of dinosaurs. You should now be making links between Module 1, where we looked at human evolution on the continent of Africa, which spread out onto the rest of the continents, and this module, Module 2, which looks at the time before any life forms on the planet, where you get to explore and research and look further into where the actual landmass of Africa came from, the beginning of Earth itself. And when we go further into detail of geological time, we see that there have been 3 major supercontinents, with the last one called Pangaea. Pangaea meaning all Earth. And when you take a closer look at Pangaea, you'll see that the landmass that we call Africa today was the hub of Pangaea, slap bang in the middle of Pangaea, where all continents that we know today have broken off that landmass, which I feel is quite significant. I hope this module has continued to elaborate on the notion of all things being connected. This module in particular shows that everything came from one. And what's more interesting is, if I'm to throw a question out there about the moving of landmass, geological time, history and geography have shown us that land has been moving and hasn't stopped moving. So does that mean that it's still moving? And if land masses, tectonic plates, continents are still moving, then how will the Earth look in 100,000 years from now? There are theories out there. Do your own research. Go take a look at what experts are saying the Earth will look like in the future. It's very interesting. We are now approaching the end of this session, but before we conclude, it's time to check your learning. Are you able to discuss what is meant by the continental drift theory? Are you able to state the difference between an eon and an era? Can you recall how old is the Earth? And can you describe what happened to the Earth from the Precambrian eon to the Cenozoic Era? Name the current era. Describe what may happen in the future to Earth's tectonic plates. We have now come to the end of this session. Well done. If you have completed all the questions and fully comprehended the content, you should be very proud of yourselves because this is quite an intense module. You may have to rewind and revisit to make sure that you fully comprehend what was discussed in this session. I want to thank you for taking time to listen to my session. I hope you enjoyed it and I look forward to receiving your feedback. Thanks again, and I will see you soon with the last part of Module 2.